All right. So the difference then in the compass, where north is 0, east is 90, and the unit circle is that your east direction is really your 0 degrees on your unit circle. That north is your 90, west is 180, and south is 270, right? So they start in a different spot and they go opposite directions. So what happens is in these problems, they give you the direction based on your compass, and you have to convert it to what would that be if it was in the same spot on the unit circle. Because when we're given direction and we have to find components, we use sines and cosines, which means we have to use unit circle values, not compass values. So usually what you'll find is after we go through the first one, the hardest part for these is figuring out your direction. Once you figure out your direction, then you're good to go. All right. So what we're going to do with this is we already talked a little bit about that your navigational bearings are measured from the north. So you have to convert these to your unit circle. It says sketch 2 graphs. The idea here is that when we're sketching graphs of the vectors that they're giving us for the airplanes and the wind. So that way we just have a visual of where those are sitting on our axis to help us figure out where that would be on the unit circle. We have to identify the speed and magnitude. Remember, your speed is your magnitude. And then we have to identify the direction, which will be the angle that it's flying at. Your angle that they give you will not be the same as the angle that you use. You won't, like if they tell you that it's flying in the direction of 60 degrees, you're not using 60 degrees. 60 degrees navigation is different than 60 degrees unit circle. Same thing for the wind. Then we're going to go through write components, add them together. So this right here is kind of all of the steps, which will help you once we've gone through the problem. And then if you're going back and having to remind yourself what those steps were. But to go through these all right now, just talk about them, won't really make any sense to you. So we're just going to work through this first example. So we have an airplane with the airspeed of 210 miles per hour. So I'm going to use P for my vector for my plane. And when we're writing magnitude and direction, we can actually use just a regular bracket. The first number is your magnitude. The second number is your direction. So now before we write 75, because it says it's flying in the direction of 75. So take a look at this picture. So in the direction of 75 will be the idea that that's from the north axis, 75 degrees in a positive direction. So that's what the in the direction of 75 means. So what you have to figure out then is the angle measure you're using is how far would it be from the x-axis, which would be our 0 on our unit circle, up to that vector. So if it's 75 from the north, then this would be 90 minus 75, would be that angle measure. So we're going to use then 15 for the direction of our plane. For your wind, we go to the wind. It says the wind is blowing 50 miles an hour, so that's the magnitude, from the direction of 150. So now this one's even trickier because it's not blowing in the direction of 150, it's coming from that direction. So first think about what that even means. If I were to tell you the wind is blowing from the south, the wind's coming from the south today. So if it's coming from the south today, it's actually blowing north. So it's blowing 180 degrees opposite of what it tells you it's doing, right? If it's south, it's actually north. So when we look at this coming from the direction of 150, what I would do is first figure out where would 150 degrees be from the north. So in the north, if I were to go around 150 degrees, I'm going to get here. I think the easiest way to do this would be you actually want the opposite. So this would be the 150 degree vector, but we want it to go the opposite direction. So for me personally, what I do is I figure out what would it be if it was in the direction of 150. So how far would it be from here to here? Remember, we know that the whole thing was 150. If we were to just go from here to here, that would be 90, right? So then to get all the way to 150, then we would have to say from here to here would be another 60 degrees, but in the negative direction. So this is negative 60 degrees right here. And because we want it going the opposite direction of that, because it's coming from there, whenever you need it to go the opposite direction, the same way when we were doing the inverse tangent and we wanted it to go the opposite direction, you had to add 180 to it to get it to go the opposite direction. So negative 60 plus 180 means that we're actually using the angle 120. Which when you look at this angle, if we were to have to figure out from here to here, that's 120 degrees. Because if you go to the y-axis, you're at 90. From here to here would be 90. And then you just have another 30 degrees right there. All right, so those are your magnitudes and your directions. We want to add these vectors together. But when you add vectors, you need to add when they're in component form. And right now we don't have the components. We have the magnitude and we have the direction. So this takes us back to what we just did in 6.3b. In order to find the components, we have to find the a and the b value. So remember, your a value in general is your magnitude times the cosine of theta, and your b value is the magnitude times the sine of theta. So we're going to get components for our plane vector and components for our wind vector, and we're going to add them together. So our plane vector, I'm going to call this A1. To find the components for that, I take the magnitude, which is 210, times the cosine of the angle. And to find my B component, I take the magnitude times the sine of the angle. And then you have to do the same thing for wind. But these components we'll call A2, which would be magnitude cosine of the angle. And B2 would be magnitude times the sine of the angle. So to save you some time, to find your components, we're going to add A1 plus A2, and that will be our new A component. And then we're going to add B1 plus B2, and that will be our new B component. So rather than calculating each of these individually and having to write the decimal, what I would recommend is that in your calculator, you actually just type in your components. So for your A1, you type in 210 cosine 15, close your parenthesis, and then you would type in, you would add that to your A2 component, which is 50 cosine 120. So just type that all in one line. And so then you find out that your new A component is 177.844. And then we have to do the same thing for the B components. So our first B from our plane was 210, and we're going to use sine 15. And then we're going to add that to 50 sine 120. And so we get our new B component is 97.653. So this is like your new A and your new B value from when you've added your vectors. So it's the idea that a plane's flying, wind's blowing against it. What is the actual magnitude and direction, right? So this is your A and your B, which are not your magnitude and direction. They're your components. So now you have to go back and convert it back into magnitude and direction now that you've added them together. So remember, your magnitude is your speed, and your speed is the square root of A squared plus B squared. That's your magnitude formula from your formula sheet. So if we use our A and our B, our speed is going to be the square root of 177.844 squared plus 97.653 squared. And you should get, did you get 202.891? 202.891. That's your speed, so we would say that's miles per hour would be our label on that. Your direction, remember, is your theta, so that's your inverse tangent of B over A using your formulas. So theta will equal the inverse tangent of our B value, our 97.653, over our A value, 177.844. So you get 28.82 degrees. All right, you want the bad news? You're not done. Because this angle measure was from a tangent, which means was from the unit circle. So this 28 degrees, we get rid of all this. This 28 degrees represents this vector that's right here, and this angle measure from here to here is 28 degrees. But we need to tell the pilot the navigational direction, which would be from the north to this vector. So to find that navigational direction or your compass direction, so whenever you get done, you always have to do your compass direction is going to be 90 minus whatever your theta was that you got. So every time that will convert it back to that compass or, so if we do 90 minus 28.82, we get 61.18. So we're 68.18 degrees east of north, rather than saying 28.8 degrees north of east. All right, so we're going to go through another one because now we've done it all and we're ready to practice it one more time, and then you have your worksheet. Right. Oops. All right. All right, so here we go. An airplane is traveling at a speed of 724 kilometers per hour. So if we start by writing out our magnitude and our direction of our plane. Our magnitude is 724, and it's at the bearing, so this is your direction, of 30 degrees. So do we ever use the same angle that they give us? No. So we need to probably, if you can't visualize it, draw a picture. So 30 degrees, that's from the north, rotating in a clockwise direction. So if you were to rotate 30 degrees from the north, you'd be going from here to here. That's 30 degrees. That's what we're looking at. So if you were thinking about the unit circle, because that's the angle we want to use, how far would it be from the positive x-axis in the other direction up to your vector? 60. So we're going to use 60 degrees. Now if we go to the wind, wind has a velocity of 32 kilometers per hour, and it's coming from the west. So if it's blowing from the west, that would mean it's blowing towards the east. And on the unit circle, what would be the angle measure of that blue arrow? 0. Or could you use 360? Yeah, they'd both be the same, but we're going to use 0 degrees. All right, so now you have magnitude and direction. We want to add these together, but remember, to add them together, we need to be in component form. So we have to find our components. So let's list our components. Our first component, our A1, we do magnitude, so 724, cosine of theta of 60, and our B component will be 724 sine 60. And then for the wind, we're going to do the same thing, but we're going to label them A2 and B2. So our A component for wind, we use magnitude and direction. So 32 cosine 0. And our B2 would be 32 sine 0. So to add our two vectors together, to add P plus W, we need to add our components. So our A1 plus A2 and our B1 plus B2. This is where you don't need to write out all of that because you're just going to probably type it into your calculator. So kind of what I'm writing down would be the work that you would want to show. So we're going to do 724 cosine 60 plus 32 cosine 0. And so we get 394 for our new A when we add those together. 724 sine 60 plus 32 sine 0, we get 627.002. And so those would be your components of the two vectors once you add them together. Right. So then remember, once you have those two components, you need to find your speed, which is really just your magnitude. So the speed is going to be your square root of your A squared plus B squared, or your 394 squared plus your 627.002 squared. You get 740.518. Which seems really fast, but you realize, are we in miles per hour here? We're in kilometers per hour, which is a little bit more reasonable. Right? Most planes don't travel at 740 miles per hour. That would be really fast. And then your direction will be your inverse tangent of B over A. So your 627.002 over your A, your 394. We get 57.659. But remember, that's your unit circle. So we have to get your compass direction. Which is going to be 90 minus that angle that you got, the 57.69, sorry, 659. So 32.341. So that would be your direction, and that would be your speed of that plane and that wind acting against each other.